Hello, welcome to Aircraft Maintenance Practices. In this lesson, we will identify, select and interpret the specification of solid rivets, describe the application of heat-treatable rivets, explain the failure mode of a riveted joint, describe the preparation of rivet holes. The last two statements are more referring to the practical session where we will learn to operate hand and power tools for sheet metal repairs and also to carry out installation and removal of solid rivets using a pneumatic riveter and drill. So why do we carry out riveting? The purposes are for skin to spar and ribs attachment as shown here. Alright, to join spar and rib sections, secure fitting in this case, shown here, riveted. Of course, also to fastening bracing members. Rivets are classified under two major groupings, solid and blind riveting. So in this chapter, we will talk more about solid riveting. Solid rivets. Rivets are classified by their head shape, size and material. As you can see, there are 5 rivets shown here in the slides. The two in yellows are currently used on aircraft manufacturing and repair, while the 3 are old type rivets which are not readily available or readily used in the market now. AM455 or AM456 is a brazier head type, being replaced by MS470 as shown here in yellow. Alright, AN455 and AN456 are the type of reverse brazier head usually used where thin sheets are being joined together. Flat head AN442 is used where clearance is necessary and mostly in internal structure. Round head AN430 is also where internal structure as the tension is required for two thicker sheet material to be joined. Coming back to MS20470, okay, is where higher bearing load carrying capacity is needed. Most of the time it's also used in internal structures. For flush head, AM426 or MS20426 shown here is a 100-degree countersunk head. Is used where aerodynamic is a concern, okay, or when you install protruding head which may cause obstruction. I give you a full moment to read through the slides here before I move on. So this table shows the types of rivets available and an overview on the advantages of various rivets head and series. So let's go through this 2000 series and 7000 series. It's commonly found in aircraft manufacturing and repair installation. So if you to recap back unit 1, what we mentioned, the 2000 series, the main alloy is copper. Alright, the main alloy is copper in the aluminium rivets. How about 7000? 7000 series, the main alloy is zinc. So what are the differences? 2000 series, the rivets are easier to install, and because it's a softer rivets due to the copper alloy itself is very ductile compared to 7000 series. 7000 series offers a higher shear strength capability, right? And let's move down to the head types. We have flush and universal. All right, MS20426 is flush. In this case, the advantages of using a flush head would be it reduce or so-called minimized drag, where aerodynamics is a concern, where head clearance is a concern. While universal head is used when you want to have a better fatigue life, higher static joint strength. Of course, universal head is easier to install and it has a better hole fill capability compared to flush head. Alright, you will understand what I'm trying to say when you carry out the riveting process practical work. Rivets material identification. There are markings on the rivet heads to identify what types of rivet materials are being used on aircraft structures. But of course, the correct methods to know what is the right rivets to be installed will be the aircraft drawings and structure repair manuals. Alright, if you found a rivet without any marking on the floor, it tells you that it's a A-type rivet where it's a 1000 series aluminum alloy. 1000 series aluminum alloy, we know that it's a 90% pure aluminum content, so it's literally very soft and weak. So the shear strength itself is only 10,000 psi. The heat treatment part here is referring to as known. What do you mean by that? It's very simple. That means this rivet itself does not require any heat treatment process to be installed. So that means you don't need to put inside an oven to heat treat it prior for installation. Same thing goes to the next rivet AD. AD rivet is represented by a dimple or an indent on the manufacturing rivet head. It's a 2000 series aluminum alloy. It can be installed directly without heat treatment, and the shear strength it provided will be 30,000 psi. The next two rivets are very interesting. They are known as icebox rivets. They are D and double D. To identify a D rivet, there's a raised dot or a tit on the manufacturing head, a raised dot. Right, double D itself is a two raised dashes. All right, so both are actually 2000 series, same thing. The main alloy is copper, but then these two rivets, before you install or carry out riveting, you need to heat treat them by putting inside an oven. Right, once you complete the heat treatment, you took it out from the oven, you must install, in other words, you must install the rivets within 20 minutes. If not, then it will be too hard to be riveted. So if you were to install these D and double D rivets without heat treatment, right, the consequences will be you may form the cracks at the upsetter head, or in fact you cannot even proper rivet. The upsetter head will not form. So why is it known as an icebox rivets? Let's say, it's an analogy for you to understand. It's the same thing like why you put ice or ice cream inside the icebox to prevent it from melting. So same things, we put the ice, the so-called the D and double D rivets, heat treated rivets inside the ice box or a container cooled by a nitrogen liquid, is to retard the aging. The term aging is referring to prevent the rivets from getting back to its hardness. When you heat treat these rivets, right, it's actually soften the rivets for it to be driven during riveting. Right? So the main advantage of using so-called processes, so many steps compared to direct installation is offer a higher shear strength compared to those non-heat treatable rivets. 34,000 psi shear strength for 2017D rivets, 41,000, which is almost as good as 30% strength difference between AD rivets for double D. The next one will be a B rivets. It's a 5056 aluminum alloy rivets. It's a raised cross. Alright, not very commonly used. 5056. What is the main alloy? It's a magnesium. Okay, you can refer back to your unit 1 notes. Magnesium, where you also require no heat treatment. Okay, you can install directly, where it offers you a 27,000 psi shear strength. The last two they are steel type rivets. Okay, no marking or recess. It's the F type, which is known as a corrosion resistant steel. And double dimple, alright, is a M type, which is the Monreal, where you can look at it, the shear strength is quite high, 75,000, 55,000 psi. So where do we use so-called steel type rivets compared to aluminum? Of course, I mentioned the correct approach will be refer to aircraft drawings, and SRM, they will tell you where to install. But the general rule of thumb is we install steel rivets types where there's a high operating temperature environment, engine area, all right? That is where we and also to take note is the F and M type rivets require no heat treatment. All right, so there's only two types, D and double D, that require heat treatment. Okay, I give you a few moments to look at this before I move to next slide. All right. MS specification. MS military standard. How do you know whether the rivets are to the specification manufacturer? So the history of aviation, okay, or so-called where aviation started off was from World War II. So during World War II and onwards after World War II, the military is the one that manufacturing aircraft, so they set the standard. So that's why there's an MS standard, military standard. Okay, but if you were to move forward, where you have a Boeing, Airbus, Embraer, Bombardier, Comet, they have their own specification standard. So they call it NAS, National Aerospace Systems, or their own body to control the car qualities. So this is the old school. MS-2042-6, it tells me that it's a flush head, where MS-20470 is a universal head. So this is a universal head, this is a flush head, a countersunk, where it's 100 degree. So over here mentioned MS-20470, it tells you what type of head types. And remember the AD, material code, AD. So AD, from there, I know that it can install directly. If it's a D or double D, you need to heat treat it. So actually, you look at this MS-20470 AD-4-7. This is actually a part number for you to order. I mean, when the parts that come, you know that the person who ordered this is actually he wanted a universal head rivets, which material type is 2117 aluminum alloy, and the 4 and 7 will tell me something. So what does the 4 and 7 tells me? All right, 4 tells me the first digit, the first digit position after the AD, it tells me the diameter of the rivets, and it's measured in a 32 seconds of an inch. What do you mean by that? In other words, if 4, that's the nominator. The denominator is always 32. So 4 over 32 is actually, like shown here, is actually 1/8 inch diameter. That means the diameter of this rivet is 1/8 inch. All right. If you see a 5, then it's 5 over 32. You see a 6, is 6 over 32, which is 3/16, and so on and so forth. So the increment is always 1 over 32, as mentioned here in the slides. All right. So if, let's say you want to install a 532, then you have to put AD-5. Okay. If you want to have a, I mean, if the SRM mentioned D, then you change the AD to D. So the head type remains the same. It's either MS-20470, which is a universal head, or MS-20426, which is a flush head. All right, so this thing will play a part, A, D, D, double D, F, and diameter. Okay, second or last position, the 7, represent the grip length. Okay, the grip length is shown here, the length. So actually, you look at it, the grip length, later we will talk about it, how do we calculate the actual length needed. So the grip length itself, if this is 7, to take note as the denominator is 16. All right, different, diameter is 32, length is 16. That means it's 7 over 16 inch long. All right, so if you see a 8 in this case, 4-8, all right, if let's say, wait, if this is changed to 8, all right, so that means the length is 8 over 16. So actually the length is ½ inch long. or 0.5. All right. So the next equipment 9 will be 9 over 16, you know. So just take note of that, the difference. The definitely question will be asked on what is the rivet diameter and the length, right? So I give you a few moments to read through the slides if you need to. All right, this is a NAS, National Aerospace Standard Coding on rivet. It's actually used on a commercial world, started off by USA, Boeing. All right, so Boeing have their own systems. That means on the aircraft drawings itself, you need to inform the installer what type of fasteners to be used. So it's impossible, especially later there's an example to show you, it's impossible for you to put the part number on the aircraft drawings. So they utilize a cross code in this case as shown here. Okay, a cross to denote as a fastener to be installed. All right, so the top left quadrant is actually a fastener identification code. In this case, example one here, social BJ. Okay, it is given like your student number. So every individual will have their own respective student number, where the student number will not be repetitive. Nobody will use it, only you. All right, so if let's say BJ denote MS20470, so it will be that. All right, so if it's a BB, in this case, is MS20426. So I know that BJ is asking me to install, the aircraft manufacturer is asking me to install a universal head rivets AD. And this is MS20426 AD is BB. All right, there are more example later part. So the top left quadrant is fastener identification code. Okay, the bottom left column or bottom left all right, quadrant, right, is actually whether the manufacturer wants you to carry out dimpling process or countersinking process. So what do you mean by that? Later I'll explain further down the slides. So on the top right here, the top right sector here, the quadrant is actually denotes the rivet diameter. All right, and where do we install the manufacturer head? Right. So using this example here, you have a BJ, we know that's MS20470AD. For N, the 4 represent the diameter of the rivet. Coming back to that. So what does a 4 represent? 4 over 32 or 4 over 16? All right, is it 4 over 16? Sorry, 16, not easy. All right, or is it 4 over 32? Previous slide we talked about it, right? Always remember what is the rivet diameter. Then of course the bottom right quadrant here, okay, bottom right quadrant is the fastener length. Sometimes it may not appear. Okay, in this case this is 5, so that means we'll come back to that. If it doesn't appear, you have to measure on site. That means you have to get a grip gauge. Okay, a grip gauge is a measuring tool where you will measure and you will tell you what is the length of the fastener needed. All right, so in this case, this example 1, it shows you 4 and 5. 4 is the diameter. How about 5? All right, is it 5 in this case? 5 over 16 or 5 over, sorry, 5 here, okay, over 32. You can see, if you're not sure, you better go back and read up again, or go back to a previous slide, because question will be asked. All right, so the N part here, there's an N. Okay, the N, this is not easy to explain, especially over the slides. The end part is near side. That means if you were to install based on the aircraft drawing, your manufacturing head will be facing you, while the upsetting head will be far away. So that's N or F. This will be better explained during the practical session, right? Okay, so I give you a few moments here to read and digest what we talked about before I move on. So this is the typical example of rivet coding NAS 523. To take note is this is let's say as mentioned, this is used by US or American manufacturer. So if you, let's say example, you work on Airbus or you work on Embraer, Bombardier, then it may be different. But of course the standards, the format or the way of methods of working to install rivet is the same. So in this case example, BB represent MS204268D. Right, so this BB will not be used again. So the next code BA is MS204268. So all these code represent various type of rivets or fasteners, not just rivets, fasteners. All right, it can be bolts, it can be blind rivets, it can be solid rivets, it can be high locks or special fasteners. So the listing can be exhaustive and a lot. So everything is based on the manufacturer data. All right. So this is the one that I'm referring to. Aircraft drawings. This is just one small section of aircraft drawing. In fact, if you look carefully on the right here, this picture, of course, is the aircraft interior where the cabin, all right, and it's being all those aircraft panels are being removed. This is the actual structure where this is the window pane, the exit door, window pane, and so these are the frame of the aircraft. There are various frame. Okay, the frame runs through the whole shape. Okay, circumference of the aircraft floorboard, and here are the stringers or longerons. I think longeron is below. These are all the stringers. So if you look carefully, this picture actually reflected as the frame here. So these are the frame. You can see. Can you see this shape? What is this? What is this? It's actually your stringer, a head stringer, Okay, then this is your, they call it tie rack. Okay, stiffener, you want to put it that way, stiffener. Okay, to reduce oil canning on the metal. So what's oil canning? You can think about it. All right, so actually you look at it, can you orientate yourself or not? So this whole thing is actually looking the view of this way, looking up. All right, where this portion here is here. All right, the stringer runs through here, stringers. So these are the two stringers. Okay, right. So so if this is the aircraft drawing, if you are trained, okay, you should know that there's a XZK, X-ray Zulu Kilo. All right. So it tells me that if I go back to the manufacturer reference code page or documentation, XZK, it tells me that it's a BACR 15BB60R. This part number is slightly different, I mentioned earlier. Earlier we have MS military standard for 20470 MS 20426. Okay, let's write down here. Still remember MS 204, yeah, sorry, 70. Okay, then you have a A, yeah, A, okay, then dash A, 6 dash 5. So this is actually a part number. Okay, military standard 20470. So if you work on a Boeing, in this case this is Boeing, it's actually in fact Boeing BAC, and it tells you that Boeing have their own standard. So BAC represent Boeing spec and R is rivet. This is how the code run, and 15 is just a number. So BACR15BB. So it tells you that it's a protruding head rivets for bowing. 6D, the 6 is still the same thing, quite similar. The first digit after that alphabet will be the diameter, and it's over 32. So they maintain the same standard. They maintain the same standard. Okay, and it's a D type rivet. Please don't confuse. This DBB is just a code, but the D here is actually the types of rivets. D types, and it's an icebox rivet. So 6 over 32 is 316. So from here I know that, and let me go back to my laser. From here I know that this portion here is installed with a rivet. So it goes on. So you may have let's see, X-ray Tango, and J is Juliet. Yes, X-ray Tango Juliet, XTJ. So that's another type of fasteners to be installed. So you can see that this is how the aircraft manufacturer communicate with anyone across the world when they maintain their aircraft. Okay, so Boeing will have their own standard methods to communicate. Airbus will have their own, but all utilize the same methods is aircraft drawing, just that certain formats are different. Now comes, do you see all those blank? What does this blank plus represent? Okay, over here mentioned that the blank plus symbols between two fasteners indicate same fasteners is used at all locations. In other words, if this is XZK6 and XZK6, then all these 4 remaining fasteners will actually install BACR15BB60 rivets. Do you see that? All right. So of course, if you look carefully, you have this is 8F. So it's 8. Okay. Just take note. We will talk about this when we cover the fasteners. But over here, this is a bolt. Okay, it's a protruding shear head hex drive bolt. Bolt is slightly different with rivets when it comes to the diameter. In this case, bolt, the diameter denominator is 16, which is mentioned here. Okay, 8 over 16 is 1/4. This one we will cover during the other topic, the other unit, fasteners. All right. So having said that, you can do the example further by by yourself. All right. So I give you a few moments to look at what we have. This is a real work that we carry out in the real world. So you can't always call Boeing when you want to install something and ask them, hey, what rivet should I use? So Boeing will actually have an aircraft drawing or SRM to tell you how to install and what to install. So you can see there's an F here. So F is referring to the far side. That means when you install the bolt, right, the bolt head will actually at the opposite side. And what you see here will be the nut. So that's far side. If it is an N, in this case, I say again, if this is 8N, okay, let me write down, easier. 8N, if let's say you have this cross and it's 8N and it's XT, same thing, XTJ. So in this case, this side, near side is referring to this side. That means when I install, I insert in the hole, it will be my fastener head. That means my fastener bolt. I install my fastener bolt in this direction, inserting in, and behind the attachment will be my nut. But if you see a far side here, the fastener bolt was actually installed from the other side of the frame, and what you see here will be the nut. So that's N and F. It's not easy to explain, but let's put it in a perspective. The side view is easier. Okay, the side view, use the side view. So I try my best to draw. So this is the structure that you want to install. Okay, this is the structure you want to install. So view looking at this direction. That means you're standing here to look at the direction. Okay, that means you're looking at this direction now. Okay, we are looking here. So you're looking here. So this is the structure you want to install. Okay, side view. So this is a side view. So if get me my pen, let me change the ink color. Okay, I use pen first. Then I change the color. Give me a minute. Okay, so if it's a far side, that means when the installer does right, you will install the fastener bolt here. Okay, then I use another color again, easier for you to understand. Then the nut will be tightened here. So the nut will be here. Okay, the bolt head itself will be at the far side. So if this is the end, in this case, if let's say it depends on orientation. If the diagram shows you this is the end, so that means, in other words, what I would do is let me erase away. Give me a minute. Easier. Oh, easy. Okay. We are comparing the installation of rivet versus hex drive or lock bolt. The advantages of rivet installations are lower in cost, cheaper, suitable for automation, minimize foreign object debris during installation, better hole filling, yes, and lighter in weight as compared to hex drive bolts or lock bolts. Of course, the advantages of hex drive or lock bolt installation will be easier to install. They have a higher joint static strength as compared to rivets, better shear and tensile strength, greater clamp up loading, and of course, greater fixity for compression applications. Hex-drive bolt in terms of that will be more expensive compared to rivets. So I think the suitability for automation also play a part where aircraft manufacturer prefer to use riveting installation than hex bolt drive. Of course, end of the day, it depends on the loading part. If the load is too high, then installing of rivets may not be suitable. Then they go to hex drive or lock bolt. One of the example for this type of application would be the wing root to the aircraft structure installation. It will not possible to use rivet as the loading, the flexing of the wing, okay, will be too much for the rivets to handle. So lock bolt or hex drive bolt, lock bolt in this case would be a better application. Diameter and the length of the rivets. Okay, the diameter will be determined by the aircraft manufacturer, okay, through the aircraft drawings or the structure repair manual. So just one thing to take note is the denominator for the diameter rivets is always 32, right? So if you see a 6, then it's 6/32 diameter. So how do we determine the length? As per the statement here, rivet's length, sometimes known as rivet's grip length, all right, grip length is equal to total material thickness, all right, 2 pieces, or can be 3, total material thickness plus 1.5D, all right, where D is the rivet's diameter. All right, ignore the 1.25, the standard practices everybody using will be 1.5D. So as shown in the diagram here, so total thickness plus 1.5D will give you the grip length. This is prior to bucking of the rivets. After the riveting process completed, this is the end result we want to achieve. But to what extent, after that, when you have correctly upset the head, okay, the upsetting head, okay, this is the manufacturing head. The one is done by the manufacturer of the rivets. Below part is by us, sometimes known as shop head or upsetted form head. So there are various terms for it, but this is by us. So after we carry out the riveting process, we were supposed to measure the dimension of the workshop or upset the head. So if you measure the thickness of that, it should be 0.5D. Okay, 0.5D. Then the diameter of that will be 1.5D. That is the upset the head. So this picture actually shows us how is riveting being carried out. There will be a riveting gun here and a bucking bar. So the riveting gun will be on the manufacturer head side, while the bucking bar will be at the shop head side. This will be, we will talk about this more when we carry out practical work. So drill size for rivets. Anyway, before we install a rivet, we have to ensure that there are holes being drilled out so that my rivets can be installed. So how do you communicate to the two-store gentleman that you require certain drill bits? All right. So of course, let's say using a 316 rivet diameter as an example. If I want to install a 316 diameter, in this case, rivet, if you were to tell the two-store guy, I need a 316 drill bit, he will give you a 316 drill bit, which will give you a 0.1875 hole, plus minus that, 0.1875 inch hole. And your rivet diameter shank, the rivet itself is actually 0.175. Do you think that you are able to install the rivet into the 0.1875 inch diameter hole? This type of hole is known as interference, right? Interference, all right. And the rule of thumb is the hole for rivets, all right, the holes for the rivets are supposed to be slightly bigger. Reason is when you buck the rivet, the process will compress the rivet and expand the shank. So your holes, your hole, the bigger hole is supposed to be able to cater for the expansion. So that's why you have some clearance in this case shown here. All right, and your rivets before installing is supposed to be loose. Once you buck, okay, once you upset the head, the rivet, then the shank of that is supposed to expand due to the compression loading on the rivet heads. All right. So if I want to install a 316 rivet, the actual drill time or the actual hole diameter I supposed to achieve is actually 0.191. That's bigger than 316, right? As shown here. So of course, if you look at this column, the drill number, this is the one that we communicate about, be it from technician to technician, engineer to technician, or even you're going to book up the toolings from the two-store guy. Everybody will mention drill bit 11. So when we talk about drill bit 11, the common consensus will be it is a drill bit that give me a hole diameter of 0.191 inch. So this is the common. So if let's say I want to install a 1/8 inch diameter, then of course I go to a two-store, I tell the gentleman I will give me a drill bit number 30. So on and so forth. So this is there are a huge variant charge. This is just one small part of the diameters used. So there's a list of chart to be referred to, so we know that which drill bit number to call for when we want to install various size of the rivet diameter, right? Okay, crack cone color. We will talk about the crack cone. What is crack cone for? But to take note is there are various crack cone for color coding for various diameter hole. All right. So silver is for 332, copper 1/8, black is 532, gold is 316, green is 1/4. We will talk about this when the slides appear in later part of the presentation. Okay, so let's move on. So this is meant for flush head rivet installation, MS20426 types of rivets. All right, when you install a flush type rivets, the reason so is it does not have any protrusion. So it reduces drag from drags on aircraft. So these are more installed on the aircraft skin structure, where minimize drag and of course will not cause aerodynamic issue. So the one of the extra step as per compared to installing a protruding head rivets is you have to carry out countersinking or dimpling process. Okay, so when do we carry out countersinking or dimpling will depends on the sheet material thickness you want to install. If the material is thick enough, okay, then you are able to do countersinking. If the material is too thin, example 0.040 inch and below, you are supposed to carry out dimpling. If you were to choose to carry out countersinking at a thin sheet material, you will actually create a sharp knife edge. Okay, what do you mean by sharp knife edge? So let me get my pen. All right. As per, if you look carefully, if you were to do a proper countersinking, all right, the process of that will allow you to okay. So this is the countersinking portion where you removed. Okay, we will talk about countersinking method when we carry out practical. But after you countersunk, this is the shape that you will allow your flush head rivets, okay, to be installed and flush, okay, onto the material. But if the material is too thin, all right, the material is too thin. Let me get my pen and I change the color, ink color. Let's say I use black. Okay, the other material, if it's too thin, when you countersink, you will actually create a sorry, the drawing. So actually, you will create a sharp corner here. We call a knife edge, and you will do a stress analysis, all right, and you realize that most of the time, if you have a sharp corner here, this is the local stress riser, where your failure point will start from here, where cracks will promulgate because sharp. This is a dimpling process. Dimpling process is actually a process that cause a compression loading, all right, and create an indent, okay, on the sheet metal. So you need a dimpling tool and die. So they use compressive loading and compress, while countersinking is actually cutting away material. So looking at here, this is the hole you're supposed to drill. Then you have a male and female die, and with the loading compression, and you will create this dimpling on the sheet metal. So this is where you can install your countersunk rivets. So anything smaller than 0.040 inch thickness, you have to carry out the dimpling process. Of course, the structure repair manual will tell you the material thickness for countersinking minimum, and of course, if not, you will have to carry out the dimpling process. All right. So let's move on. Loads in a riveted joint. The joint must be able to withstand shear loading on the rivets or fastener, tensile, bearing, or tear loading on the material. So if the joint is subjected to excessive loading, which is known as ultimate tensile loading, which joint should fail? There's no standard answer for this. It greatly depends on the aircraft designer with the choice of material he used and the type of fastener he installed. So if he chose to have a tear-out loading as an ultimate failure, what he can do is using an oversized material fastener and install it with the exact critical edge distance as measured without excessive allowance. In that case, when the ultimate load is applied, both sample with different diameter, the lower sample piece will experience a tear-out. All right, a tear failure. But if he choose to have a bearing failure, okay, then the failure mode will be elongated hole. This is the current type of bearing failure commercial aircraft companies chose to use on. While very beginning of the commercial aircraft design, the engineer chose to have a shear loading failure on the fasteners that is under this mode. So it's either a joggered rivet or actually a missing fasteners. So that constitute into a failure in fasteners. All right, ultimate load distribution based on bearing critical failure. That means if they design to have a bearing critical failure mode, you realize that the whole elongation will be the joint failure and fastener deformation throughout the joint will be uniform. This is done by one of the aircraft manufacturer. So when the ultimate loading uh, is applied through, you realize that at this all the fastener will take up equal loading and transfer the loading across. So that's why they choose to have the lowest margin of safety for bearing failure. That is the current design. We do not know subsequently will they change it, but this is the current structure they are doing for sheet metal, right? Ultimate load distribution. This particular installation or design will be fastener critical. That means when ultimate loading is applied to this joint, all right, the fastener will fail. As compared to previous installation where it's bearing critical, all the fasteners will take up equal loading, but not in this case. In this case, the end fasteners will see higher deformations and in turn higher loading than the middle fasteners, right? So this will occur during aircraft normal operation loads and in joints that are not bearing critical. So in that case, when there's ultimate failure, right, it will cause a catastrophic unzipping of the joint where your fasteners will actually joggered or missing and shear off. So this is the earlier design concept the aircraft manufacturer choose to apply to. Then over a period of time, they decided that bearing critical will be more suitable in their design philosophy. All right, types of rivet layout. It can be single or multiple rows. So single row is used mainly on attachment where it's lightly stressed joints, and multiple rows will be used on watertight joints or places where stress loading are higher. So, but then again, all aircraft structures minimum will be 2 rows instead of 1. And of course, they also add up to 3 rows, to counter fatigue loading, fatigue loading. Do take note that the edge distance is the minimum of 2 times the rivet diameter used. And the pitch distance is given as the range of 4 times the rivet diameter to 6 times the rivet diameter. In short, it's 4 to 6 times the diameter of the rivet used. What is pitch distance? As shown in this diagram, is the distance between the center of the adjacent rivets that hold together the parts of a built member. So a pitch distance is the distance between the center of the rivets to another center of the rivets. So this is pitch distance, right? So recommended pitch distance range is 4 to 6 times the diameter of the rivet. Example, let's say the rivet diameter is 4 mm. So the range is 4 times 4 mm will be 16 mm and to 24 mm. Anything between 16 to 24 mm range is a recommended pitch distance based on this recommended calculation. Edge distance. Minimum edge distance required is 2 times the rivet diameter. Using the same diameter 4 mm, so the minimum edge distance measured from the center of the rivets to the edge of the plate will be 8 mm or 9 to 10 mm. So minimum. 7 mm will not be allowed because that's less than the 2D requirement. So H distance is the distance from the center of the rivet to the edge of the material being riveted. That's H distance, right? So recap, H distance is the edge from the center of the rivet to the edge of the material, while pitch is here, center of the rivet to another adjacent rivet, which is pitch. There's an exercise which we will work on it, and you will understand better when we do the example of calculation in the aircraft structure and fastener layout drawings. Types of rivet joints. Over here we shown two types of joint, lap and jogger lap joint. And the lap joint itself is used in place where stress is low and where flush surfaces are not required. The main disadvantage is that the load are not directly opposite on another. All right. And this is the common lap joint application where easier to construct, all right, and fabricate. For jogger lap joint, the yellow plate here is actually being bent, and that joint is known as a jogger. So the underplate is jogged to preserve the continuity of the upper surface. So we can see that this is flush in line. So it provides flush surface that the load is not truly axial. All right. Then the other two will be butt joint, single stripe, butt joint, double stripes. So these type of joints are stronger than compared to a previous lap joint and widely used. Okay, the main difference will be actually this is a single stripe. You can see two pieces of sheet metal skin are joined by a plate. Okay, so compared to double stripe itself, is actually the two pieces of sheet metal or skin, aircraft skin to be joined are sandwiched between two double or stripe. So of course, loading wise, in order to counter, let's say both are experiencing the same ultimate loading of 10,000 to prevent material failure, your butt joint single stripe will require a heavier gauge plate as compared to a double stripe, right? Because you have more material here, so you could take up the loading, the piece, the two pieces take up the loading, share the loading compared to a single. So this single stripe butt joint itself, you will require a heavy gauge plate. All right. Of course, in terms of weight penalty, butt joint double stripe may occur that penalty as compared to single stripe. Hole preparation. So this is a sample picture of how we carry out hole drilling. Of course, this is a practical mode where you will experience during your practical session how to engage your drill bit to the drill gun and how to carry out proper drilling and posture to achieve the hole roundness. So this is actually a L channel where it's attached, supposed to drill a hole or pick up hole in this case onto the aircraft structure. And after that, when everything is done, the hole is drilled, then you can install with the fasteners required. So prior to that, how will you attach your L bracket to the structure will be the crickles. This is the crickles we refer to, crickles pin. This crickle pin is works as a clamp, but it's not a clamp, but it's just a crickle pin that hold the L plate before your fasteners are being installed onto the attachment. All right, so it's a temporary structure, temporary holding structure. Okay, so what differentiates the crickle will be the color. It can be silver, in this case this is silver, it can be a gold or brass, it represents different hole diameter, right? I believe coming. Okay, this is the crickle pin, a better picture of crickle pin. So you will learn how to use a crickle pin and crickle prior during the practical session. But do take note is various color coding of crico pins will indicate the type of hole diameter they should be used on. So silver or zinc will be on 332, brown or copper is 1/8 inch diameter, black is 3/32 inch diameter, brass and gold is very common, is 3/16. So our practical, you will see a gold or brass type of crico. In this case, this is the one. So if you were to use a black color crico on a 3/16 hole, you realize that the black crico will actually drop out, you will not hold. But if you were to use a gold or brass meant for 3/16 hole crico, you try to insert into a 332 hole, you realize that this crico, like this 3/16 crico, glass or gold in color, will not actually be able to insert into the 332 hole. Yeah, so that's why they have color coding for cricos, and this is a standard color coding throughout all aircraft maintenance and manufacturing sector, right? This is a standard international practice.